Good morning and Assalamu alaikum. Today, the topic of our presentation is convolutional neural networks. The presenters of this presentation are Maryam Zahra Naqvi, Akash Ali, and Fida Hussain. Akash Ali will start this presentation. Over to you, Akash.
Assalamu alaikum. My topic is convolutional neural network. First of all, I am discussing about presentation on agenda. That is why how computer read a image, why not fully connected network for image recognition, why convolutional neural networks, how does convolutional neural networks work, convolutional network use, how computer reads an image. First, we see a picture of scenery that is very colorful, but how a computer will read this image? So basically there will be three channels on the red, green and blue. Every channel will have a specific pixel value. So when we say that the image size is b into a into 3, that is mean first of all we have pixel resolution and it contains three parts, one red, green and blue, which has RGB known as. This means that B rows, a column and three channels. Why not fully connected network for image recognition? Let us see why cannot use fully connected network for image recognition. Consider an image which has 28 into 3 pixels. The total network of ways required in the first hidden layer will be 2532. But in real life, the image are not that small. The image are mostly above 200 into 200 into 3 pixels and I feed it to the fully connected network. So that at that time, the number of bits required, the first hidden layer itself will be 120,000. So we need such huge parameters. So we will require more number of neurons which will eventually lead to overthinking. So that's why we cannot use fully connected network for image classification. Why convolutional neural network? Let us see what is convolutional neural network. Why convolutional neural network? In case of CNN, the neuron in layer will only be connected to a small region of layer before it, instead of all the neural network connected to it. Now, why do we need convolutional neural network? So in CNN, a neuron in the layer will only be connected to the small region of layer. So if you consider the neuron 2 only connected to 3 other neuron, unlike the fully connected network, when the same neuron will be connected to all. The last 5 neuron, because of this, we will need to handle less amount of weight. In turn, we need less number of neuron as well. What is convolutional neural network? CNN is a type of feed forward artificially neural networking pattern between its neuron is inspired by the organization of animal visual cortex. Now, what is actually CNN? CNN is actually a feed of forward artificial neural network which are inspired by the visual context. So visual context is nothing for a small region which is present in the brain where bulb is present. Basically what happened was that experiment was conducted in which people got to know that visual cortex has a small region of cells that are sensitive to specific regions of visual flex. For example, some neuron fires when exposed to the vertical edges and some when show horizontal or diagonal edges. How does convolutional neural network work? Let us understand how does convolutional neural network works. How does CNN work? It has the following layers: convolutional, ReLU layer, pulling, fully connected. As X shown in pixel is like left image and as it actually look like X. Both images classify the pixels. Difficult cases. There are some difficult cases in which the image are deformed like all the four images of X and also O. There are the image of X and O but just deformed, so we will want our classifier to classify them as X or O. How does CNN work? So if we notice that the first image of X is proper image which is equal to the second image which is deformed, same with O. How does CNN work? A computer understands an image using pixels. So what we do is that we know that a computer understands an image using number at each pixel. So we do is that whatever the white pixel we have, we are going to assign a value to it, and black pixel we have, we are going to assign a value 1 to it. When we use normal techniques to compare the two images from which one is proper and other is other deformed image of X, we got to know that a computer not able to classify the deformed image as X correctly as it is, comparing it with the proper image of X. So when we add the pixel value of both of these image, we get the third image. So basically a computer is not able to recognize it whether it is an X or not. How does CNN work? So now what we do with CNN is that we use small patches of our image. These patches are known as features or filters. So what we do by finding rough feature matches in roughly the same position in two images can CNN get a lot better in seeing the similarity between the whole image matching scheme. What it means that we have the filter in the image. Consider the first image which is equal to the first filter in the deformed image as well. Thank you. Over to you, Fida.
Assalamu alaikum. How does CNN work? We will be taking these three features for our example. The first and third features are diagonal. So with these features, we will move forward. Now, how does CNN work? So what we will do is take the filter which are small pieces of the bigger image. We will put it on the input image, and if it matches, then the image will be classified correctly. Step involved in convolutional layer. Step 1 is line up the features and image, and step 2 is multiply each image picture by a corresponding feature picture. Multiply the corresponding picture values. So this is the first diagonal feature, and we will put this particular feature on our image of X, and we are going to multiply the corresponding picture value. So we will multiply 1 with 1 and put it another matrix, and by repeating the process we will complete the matrix. Step involved in convolutional network. Now after we complete the matrix, we need to follow next two steps, which are step 3 add them up, and step 4 divide by total number of pixels in features, adding and dividing by total number of pixels. So what this means is that after the multiplication of the value, we will add all of them and divide by the total number of pixels, and we get some values, creating a map to put the value of filter. Now our step is that we make a map and put the value of filter in that particular place, and we will move our filter throughout, sliding the filter throughout the image. This is one more example in which we move the filter to the middle and get the following output. So as we see that there are couple of -1, so we get 0.55 convolution layer. Now we will put the value of filter at that position. So we will place 0.55 in the middle. Similarly, we will move the feature to every other position of the image, and we'll see how the feature matches that area, and finally we will get as an output. We will perform the same convolutional with every other layer and get the following result. This is the second layer called ReLU layer. ReLU layer is nothing but an activation layer. So what I mean by this is that it will only activate a node if the input is above a certain quantity, while the input is 0, output is also 0, removing the negative value. So what we want to is that we want to remove all the negative value in this matrix that we can. Thank you. Now over to you, Maryam.
So now we obtain the following output of all the features. Now we'll understand the pooling layer. In this layer, we shrink the image stack into a smaller size. We follow the following step. We pick a window size, pick a stride, walk a window across the filtered. From each window, we take the maximum value. So now we move the window across the entire image and get the following result, which is 1. So now the output that we obtain from ReLU layer, we pass through the pooling layer and get the following output, which is 1.0, 0.33, 0.55, etc. This is the output after passing through all the pooling layer. Now this is the third part of the CNN, which is stacking up the layer. In stacking up the layer, first we stack up the convolutional, ReLU and pooling layer. We get this following matrix. We stack an additional convolutional, ReLU and pooling layer, and we get a matrix of 2 by 2. Now this is the final layer called fully connected layer. In this layer is where the actual classification of our filtered and shrink images begin. Output layer. When we feed X and O the values, then there will be some elements in which the vector is high. If we consider the image above, consider the image below. As you can see, for the values of X, there are different elements, and for O, there are different elements. Consider the below list for a new input image. Let's compare this list with the list of vector X and vector O. Firstly, we compare the image with vector X. We see the image of vector X in which the higher value is of 4, 5, 10, 11 other higher values which we sum, which is 1 plus 1, and as well as first we sum 1 plus 1 plus 1, which equals to 5, and similarly the same 1, 4, 5, 10, 11 values we sum of the input image, in which we get our result 0.91. For vector O, we sum 2, 3, 9 and 10. We get our sum 4, and similarly with the input image we also sum the higher values 2, 3, 9 and 10, and we get our result 2.07. We get the output 0.51. Now we see the image will be classified as X if it has a value higher than 0.9. Similarly, the same case with O. Now we understand the convolutional neural network use case. Dog and cat identifier will be our example. We feed the CNN network with images of both dog and cats. And when we start our process, we input an image of dog. And CNN will give us the answer dog. It will classify that image as a picture of a dog. Following are the steps that are involved in this use case, which are: we download the dataset, function to the encode the label, we resize the image, we split the data, we reshape the data, we build the model, we calculate the loss function, we optimize it, we train the deep neural net for 10 epochs, and we make the prediction. This is how we implement the use case in CNN. Thank you.